In this section, we're going to talk about temperature-dependent limits of performance. So first, we'll start off with endurance and aerobic performance. As core temperature increases, there's largely seen a reduction in time to exhaustion. So there is reduced aerobic capacity. You're unable to maintain that same level of output as long. So we're talking exercise volume endurance. During exercise in the heat, fatigue has consistently been shown to occur at a temperature of roughly 40 degrees Celsius. Now, there has been a lot of discrepancy about the theory that there is a critical core temperature. It's a lot more nuanced as opposed to a singular core temperature. However, it's pretty clear across all studies and theories that as core temperature elevates, there is going to be the lowering of the ceiling for work capacity. We're also going to explore later on some studies that show that muscle glycogen levels in the heat were not fully depleted. So the limiting factor for exhaustion was not related to muscle glycogen. We also see that VO2 max declines linearly with rising core temperature. The key thing here is uncompensable heat stress environments. We're going to talk about that later in the course. In this section, we're going to talk about some of the temperature-dependent limits of performance. We're going to keep this relatively short as we'll go into a lot of detail later on in the course. The first is endurance and aerobic performance. As core temperature increases above the normal boundaries, so once we start exceeding 38.5 degrees Celsius, there's a notable decrease in time to exhaustion, so the overall capacity to perform the volume of work that can be completed. Now, there was for a long time a theory of critical core temperature that at about 40 degrees Celsius, performance would really shut down. There's been a lot of theories since then that seem to disprove that. It appears to be a lot more nuanced, not necessarily a specific critical temperature, however, still a very strong relationship between elevating core temperature and decreased endurance. Interesting, something else we're going to explore later, muscle glycogen levels have been found in exercise in the heat to not be fully depleted. So to still have plenty of muscle glycogen at the point of exhaustion, indicating that it's not necessarily a metabolic limitation. And we've also seen that VO2 max declines linearly. So the big thing here, which we'll get in later in the course, is uncompensable heat stress environments. And that essentially means when the body is no longer able to compensate for the heat gain, the heat acquisition, or the metabolic heat production, it cannot keep up with cooling. Thermoregulation processes cannot keep up as quickly. We also see neuromuscular strength and power impairments. So thermal stress impairs the maximum voluntary contraction. And there's a lot of good research on this, specifically during states of hyperthermia. And this points to the overwhelming theory of central fatigue and that the brain down-regulates neuromuscular drive as a way to protect itself, much like the governor on a car. We're going to explore that later. Temperature elevation also reduces muscle torque. So again, neuromuscular strength, power, that is going to be one of the areas that is reduced in performance in states of hyperthermia. Cognition, motor control, lots of studies on cognition being impaired. A big part of this is a decrease in cerebral blood flow, as well as heat stress represents itself as a cognitive load, adding to the burden and making it more difficult to perform complex tasks such as decision-making and motor coordination. The final part of this is perceived effort and self-regulation. So the brain subconsciously anticipates risk and the consequences of overtraining, of producing too much heat, and it'll actually downregulate and also make it a lot more uncomfortable. So we see this, and I think we all have experienced this intuitively many times.